42. Calculate the equilibrium constant at 25 degrees Celsius for each of the following reactions from the value of the delta G notch given. So now we have this equation, I2 solid plus Cl2 gas yields 2 ICl gas, and they give me a delta G value of negative 10.88 kilojoules. It's spontaneous, it's a negative value. So we have to find that equilibrium constant. Remember, the equilibrium constant is a K value. Now, it doesn't specifically matter what K value we're solving for here. Chances are we're solving for Kp because I do see gases here, but it doesn't matter because there's only one formula that links equilibrium constants with delta G values. There's two variations depending on what you're solving for. So in this case, we're solving for the equilibrium constant, so it's easiest to just know it as this. K equals E, which is on the calculator, raised to the negative delta G over RT. So if we're solving for equilibrium constant, I should know G, R, and T. So let's start with R, right? R is a constant number. It's 8.314. Units, if we're using the 8.314, is joules per mole times Kelvin. So this will dictate what the other units should be, right? So for example, for temperature, this says that it has to be in Kelvin. They gave it to me in Celsius, but that's okay. I could just convert the 25 degrees Celsius into Kelvin, right? Celsius to Kelvin, that's easy. That's plus 273. More specifically, it's 273.15. So room temperature, 25 degrees Celsius. When added, the value is just 298.15. So we're good with that. Now going back to the R value, I have to use joules for my delta G, but they gave me kilojoules. But that's okay, I could just go from kilojoules to joules, right? That's timesing by 1,000. So I'm gonna just take this decimal, move it to the right 3 times. So it looks like it's 10,000, negative 10,880, and that's the number that's gonna go over here. Okay, beautiful. Now let's just plug it in. K equals E raised to the negative fraction. Maybe I'll pull this down a little bit. Okay. So my G is already a negative. It's a negative 10,880. And then I have the two values on the bottom. I got the 8.314. And then I have the 298.15. Okay. 0.15. That's good enough. First thing that I would do is I would clean this up to get it to just one number that I'm going to raise the E value to. So let's go for it. K equals E raised to the negative times a negative is a positive. So I'm not even going to bother writing in those negatives. I'm just going to take the 10,880 and divide it by 8.314. And now since I'm not using any parentheses in here, and I want to get that 298.15 in there, I'm going to press divide. That way the calculator will understand what I'm trying to do. Press enter, and there we go. We got a lot of numbers. So it's E raised to the 4.389 and a couple more numbers to come. But just remember that this is not your final answer, so don't round. So I'm not going to round the number when I do this function. So here we go. We're getting the answer. What's that equilibrium constant? I'm going to say second ln. That's the EE button. And then I'm just going to take the whole value, press enter. There it is. Press enter again. Voila. Let's add some sig figs to it. Seems like I added a lot of sig figs here. For my temperature, I only had 4 over here. So I'm going to use the 4 sig figs. So it should be 80.57. And that is your final answer. That's your equilibrium constant. Should be above 1 because you did have a spontaneous reaction, a negative value. So it does check out. All right. Thanks for tuning in. Really hope this is helping you out. Let me know in the comments. Love chatting with you guys. Good luck on your future tests and quizzes, and I'll talk to you soon. Okay, bye-bye.